So we have seen that when we have an ergodic Markov chain, we may analyze the steady-state probabilities as well as the mean first passage times. Now, if we have another type of chains, which is absorbing chain, let's see what kind of analysis that may be performed on this type of chain. So if we have a chain in which some of the states are absorbing and the rest are transient states, then we call this type of chains as absorbing chains. So here's an example for the gambler's ruin problem. You see that states 1, 2, 3, they are transient states, and then state 4 and state 0, they are both absorbing states. So this chain is an absorbing chain. The consequence of having an absorbing chains is that eventually or finally we will end up in one of the absorbing states. So if you remember the game of Gambler's Ruin game, you will finally either win the game by earning $4, or you will completely lose the game by having nothing left on your pocket. So when you have earned $4, then you may not play the game again. If you have lost all your money, you cannot play the game again either. So that's why in those situations, we model it as an absorbing states. So the probability from 4 to 4 again is 1, and then from 0 to 0 again is 1. And it is guaranteed that if we keep playing this game, we will end up in either $4 or $0. So let's take a look at an example in which the accounts receivable situation is modeled as an absorbing Markov chains. So accounts receivable means that, for example, you are selling something to somebody at this moment, and then that person says that he or she will pay you later. So you record that money as something that you will receive in the future because the person is not paying you immediately now. So that money is said to be your accounts receivable. You expect to receive that money in the future. So in this example, a firm assumes that an account is uncollectible if it is already more than 3 months overdue. So in this case, after 3 months, you just say that, okay, this person will not pay the money back to me, and then you just forget the money and think that it's just gone. Okay, so that's the meaning of saying that an account is uncollectible after 3 months overdue. Now in this example, the states are defined as follows. So the states are defined with the status at the beginning of each month. So at the beginning of each month, it says that an account may be classified into new account, payment on the account is 1 month overdue, 2 months overdue, 3 months overdue, or maybe the status of an account is already paid, or maybe because after 3 months the person is still not paying back to you, so you say that this account is written off as bad debt. And here's the transition probability that shows the probability of transitioning from a state to the other state. Let's take a closer look to the transition probability matrix. If an account is already 2 months old, it means that you sold something to somebody 2 months ago, but then up to now the person still has not paid the money to you. So the possibilities is the person is still not paying the money to you this month, so the status of this account next month will be 3 months old, right? But there is also a possibility that that person will pay the money to you in this month. In this case, the status of this account next month will become paid. And then you notice that the probabilities for other states are 0, which is logical or reasonable, because if an account is already 2 months old, of course it's it cannot go back to become a new account. It cannot go back to become a 1 month account, right? Because the fact is that the person has not paid to you for 2 months, so it does not make sense if now it go back to 1 month overdue. It's already 2 months overdue, and from 2 months it cannot go to 2 months state again because now it's already 2 months overdue. So next month it will be either 3 months overdue or it's already paid. So that's explain why these probabilities are zero. And 2 months account cannot go into bad debt because you will wait up to 3 months to decide whether this account is finally paid or going to bad debt, which is this one. So if an account has been 3 months overdue, the only possibilities are either finally it is paid, or you just say that I will forget this account and record it as bad debt. So if an account has been paid, the status of this account in the following months and then forever will always be paid. And that explains the probability 1 here. Same thing if you have an account that is a bad debt, then you just say that for all periods following this period forever, this account will always be recorded as a bad debt. So that's why the probability again is 1. And then you may notice here that paid and bad debt, those states are absorbing states, because once you go into those states, you will be forever in that state. Now, the question of interest that may come up from this situation is that what is the probability that a new debt will eventually be collected? So what is the probability that you sell something to a person at this moment? So you start a new account or new debt. What is the probability that eventually it will be paid? Now let's see another situation which is also modeled as an absorbing Markov chain. So a law firm employs 3 types of lawyers: junior, senior, and partners. And then these sentences here may be translated into this transition probability matrix. And then here it says that the firm never demotes a lawyer, means that this firm never fires somebody. Same as before, for example, if you are a senior, then you cannot go back to become a junior. You just cannot go down in your status. So from if you are in the senior state, you may go up to partner, or you may stay as a senior when you begin the next year. You may also leave this firm as an NP. NP here means non-partner. So when you leave this firm, it is divided into 2 status. Either you leave as a non-partner, means that you have not reached the status of becoming a partner, or if you leave the firm as a partner. Same as before, if you have left the firm as a non-partner, forever your status will be recorded as leave as non-partner. That's why the probability is 1. And then same thing if you leave as a partner, forever your status in this firm will be recorded as leave as partner. So some questions of interest regarding this problem. The first is that what is the probability that a junior, so junior is somebody who just joined the firm as the lawyer with the lowest rank, what is the probability that a junior will leave the firm before becoming a partner? And then the second question of interest is that on the average, how long does a junior stay with the firm? When we have an absorbing chain, usually we have two types of questions. The first question is related to the transient states. So given that we start at a particular transient state, the question is that before we are finally absorbed to one of the absorbing states, what is the expected number of times that we will enter each transient state? So for example, here the state 1, 2, 3 are transient states. If we begin in state 1, how many times do we expect to enter the state 1, state 2, and state 3 before finally we will be absorbed? Or in other words, how many periods do we expect to spend in state 1, state 2, and state 3 before absorption takes place? So the key word here is expected number of times or periods. So talking about the times or the periods. Now the second question is regarding the absorbing states. So usually we have several absorbing states. The second question is that what is the probability that we will end up in each of the absorbing states? So we know that we eventually will be absorbed, but what is the probability that we will be absorbed here or there? So that is the second question. The key is the word probability. So the first question is related to the number of times, number of periods we will spend in a transient state. The second question is about probability that we will end up in one of the absorbing states. To answer those questions, all we need is the transition probability matrix P. But first, we need to make sure that the P matrix is arranged like this. So the first rows must related to transient states, and then you must organize such that all rows that are related to absorbing states, they are arranged at the bottom part of the matrix. Same for the column, you must arrange the transient states at the first part, so on the left part, and then you arrange all the absorbing states on the right hand side of the column. And then once you have arranged the matrix like that, you may draw imaginary lines that looks like this, and then call this part of the matrix as Q, this part as R. We will use those parts to answer the questions. If we use the matrix I minus Q inverse, so I is an identity matrix whose the size is the same with the matrix Q, and then you take the inverse, it will provide the answer of the expected number of periods that we will spend in the state J, given that we are now in state I. And then if we compute the matrix I minus Q inverse times R, we will obtain the answer for the probability that we will eventually be absorbed in absorbing state J, given that now we are in state I. So let's use these two matrices to answer the questions related to the example that we've seen before. So these are three questions for the accounts receivable example. So the first one, what is the probability that new account will eventually be collected? Second question, what is probability that account that is currently 1 month overdue will eventually become a bad debt? And then the third one, if the firm's sales average $100,000 per month, how much money per year will go uncollected or will become bad debt? So all these questions are related to probability, and this is also talk about probability most likely. So from the previous slide, we know that to answer all questions related to probabilities in absorbing chains, we need to compute I minus Q inverse times R. So first, here is our transition probability matrix. Make sure that The first rows are all transient states. They already are. And then the last part of the matrix is for absorbing states. So the rows are already okay. The columns are already okay. So now you may draw these imaginary lines and then you say this part is your Q matrix and this part is your R matrix. Okay, so we just take this out. So this is Q and this is R. And then you compute I minus Q, and then I is 4 by 4 matrix because Q is also 4 by 4 matrix. So do not use this I matrix here. Just use a new I matrix with the same size with your Q matrix. And then you take the inverse for I minus Q and then do the matrix multiplication with R, and this is your final I minus Q inverse times R. I would strongly suggest you to refresh your matrix multiplication skill such that you may, and then you apply it here to compute the matrix starting from Q, R, I minus Q inverse up to I minus Q inverse times R. Now that we have got the matrix I minus Q inverse times R, let's use this to answer the questions. So the first question asks us about new account eventually collected. It means that the new account in this matrix is the first row because the first row is new account. So the first row here is denoted as T1. T stands for transient. So the first transient state, and then paid or collected is the first absorbing state. That is why it is denoted as A1. And then you just look at the number at the intersection of new and paid. So this is new and this is paid. So the intersection is 0.964. So that is the probability of a new account will eventually be paid or collected. For the second question, 1 month overdue. So 1 month is the second row. So you look at the second row, T2, and bet that is the second absorbing state. So you're looking at this number, 0.060. Now the third one says that if the firm's sales average is $100,000 per month, so this is the sales for, you can also think about this as a new account, right? Because all sales starts from new account. So you see that from new to bad debt, there is a probability of 0.036. So you can say that each month you have the transaction of $100,000. The probability that a new account will become a bad debt is 0.36. But remember, there are 12 months in a year. So this is the amount of money that will be likely to go to bad debt in this case. Now for the example of workforce planning in a law firm, the questions are a bit different. The first one asks us about average length of time. So it is not about probability. Second one asks about probability. The third one again about length of time. So from the previous slides, we've seen that to answer about periods or times, we need to use I minus Q inverse. And to answer probabilities as before, we use I minus Q inverse times R. Same as before, when you have the probability matrix P, you make sure that you have divided the rows into transient states and absorbing states, and also the column transient states on the left with the same order with the rows, and then absorbing states on the right, again with the same order, non-partner, non-partner, partner, and partner. Once you have done this, you just collect this as your Q matrix, this as your R matrix, and then perform all the calculations until you get I minus Q inverse and then I minus Q inverse times R. So the first question asks, what is the average length of time that a newly hired junior spends working for the firm? So for periods or times, we're looking at this matrix, and then this is junior. The number here says that a junior will spend average 5 years working as junior, 2.5 years as senior, and 10 years as partner before leaving the firm. So to answer the question, spends working for the firm, we just take the sum of all these categories. So the total average length of time is 17.5. Let's take a look at why we can just add the numbers for each of the possible states on the next slide. Now I make up this number to illustrate why we can take the total average of a junior working in the firm using the average of a junior working as a junior, average of a junior working as a senior, and then average as a junior working as a partner. So here in this illustration, we have 5 lawyers. They all start working in the firm as a junior. So here's the start line. And then each person have different history in this firm. If we want to take the average length of time that a person who starts as a junior working in the firm, we may just take average of these 5 numbers, right? But then actually you may also take the average of the work duration of these people by separating how many years they work as junior, take the average, and then plus how many years these people work as senior, and then the third lawyer never works as a senior, so you put the number 0, plus the number of years these people work as partner. So the third and the fourth never works as a partner, so you put 0 years there. And then you take the sum of these 3 categories to obtain the average of the length of working time for all people who start working as juniors. So this illustrates the approach that we use in the previous slide to answer the first question, which is about what is the duration of working of people who starts working as a junior. Okay, so now for the second question, what is the probability? For probability, we need to look at this matrix. Probability of a junior, so that's the first row here, because the first row is a junior. Leave as a partner. Partner is the second absorbing state, so we are looking at this number, 0.50. Now the third one again is about the average length of time that a partner will spend the time as a partner. So 20 years is the average time that a partner will spend in the firm as a partner. Obviously, because when you already have the status as a partner, you cannot go down to the lower status. Okay, that's quite long, right? Now here are some questions to check your understanding about absorbing chains. The first, given a transition probability matrix, the statement is that state new is not transient, or in other words, state new is recurrent, because from new we may go to 1 month, which is not an absorbing state. Is this statement true or false? I will give you the answer after the pause on the video to give you the time to think about the answer. The answer is false. State new is transient because from the state new we may reach absorbing states eventually, paid and bad debt, and from these states we cannot return. Now the second question, if a lawyer just starts being a senior now, he or she will spend 10/3 years as a senior before being promoted to become a partner. Is this statement true or false? So this question is asking about this number 10/3 here. The answer is false because the 10/3 number here, it means that if a lawyer is just starting being a senior now, he or she is expected to spend 10/3 years as a senior before leaving the firm as either non-partner or partner. So it's not about being promoted to become a partner because maybe he or she will leave before being promoted, right? And then the word expected is also important, which means that we cannot say for sure that this lawyer will exactly spend 10/3 years, but that is the average number of years of all the observations that we have made from all the lawyers that we have. So it is an expected number or an average, and cannot be said that this specific lawyer will have exactly that number. Okay, so we're going to talk more about absorbing chain and another type of cases on the next video. So see you on the next one. Thank you.